What's up guys, Moib here from the University of Greenwich again, and in the previous video we looked at how to work out the volume of a square-based pyramid. Now we're going to move on and look at a different shape. So on the board here we've got an example that they might ask you in the exam. This is a cone and they'll ask you to find out the volume of a cone, and sometimes they might even ask you to work out the surface area. Both of which I will go through in this video, and you should be able to do this fairly easily. Now in order to solve this, much like the square-based pyramid, we're going to be using the same formula that we'd use for that example. Alright, now that is, your volume will be a third times your base area multiplied by your height. Now in this case, it's slightly different to our square-based pyramid. Our base is of a different shape. Previously we had a square, which was easy to work out. The area was easy to work out. Now we have a circle. Alright, so what we're going to need to do is introduce a secondary formula. Alright, you should all be familiar with this formula. This is for the area of a circle. Now the formula simply is pi r squared. You should have already come across this formula before. You should already know this, but I mean, it's going to be given in your exam paper, so you don't have to worry about remembering it, but it will save you a lot more time just remembering it. Alright, so now we can plug this into our base area, and we've got all the other elements that we need to find out the volume of this shape. So let's work out the area of the circle and plug it into our volume formula. Okay? So in our example, we're not given the radius. Our R here represents the radius, right? And we need to work out what our radius is. We've been given that our diameter is 10 meters, right? Take into account that we're dealing with meters this time. In the previous video, we were dealing with centimeters. Later, this will become apparent why we have to kind of take note of this, right? But that will become apparent later. But for now, we know that the diameter is 10 meters. Okay? You should already know that your radius will be half of this, right? So we know that R equals 5 meters. So now if we plug this value into our area of a circle formula, we will get area equal to pi 5 squared. Okay? Now if you plug this into your calculator will probably give you something like 25 pi. Okay? I would suggest leaving this form and then substitute it into your volume formula. So we're going to sub this into our volume formula. Alright, now what we're going to do, we're going to plug this into our calculator and we're going to get a value of 314 meters cubed. Alright, notice that our final answer is going to have a unit of meter cubed. Alright, whenever you're dealing with volume, it's always going to be in a cubed unit. Since we were dealing with meters in our question, it's going to be meters cubed. If we had centimeters, then it would be centimeters cubed. Okay. So now that you've worked out the volume of a cone, in your exam paper they might also ask you to work out the surface area. Alright, now there's a simple formula that you can use for this also. So the formula is, I'm just going to write SA here for surface area. The formula is pi r L plus pi r squared. Now we know pi r squared is the area of our base, which is a circle. Yeah? So pi r L is just going to give us the surface area of everything else. We know what pi is, we know what r is. R is simply our radius again. L here just refers to this length here. Okay? Not our height, but our length. Right? And here at the end we've just got our area for circle. Now if we take what we have in our diagram and plug this into our formula, we will get our surface area. So we know it's going to be pi times 5 times 13, which is just the length of our cone here. Add pi r squared, which is going to be pi times, put a bracket around this just to make sure we know what we're doing. Pi times 5 squared. Right? So this section refers to our first part of our formula, and this over here just refers to our pi r squared. Now if we plug these values into our calculator, we get an answer of 283 meters squared. Notice how when we were dealing with volume, we put our units to meters cubed. In this instance, because it's area, we're going to put it to meters squared. Alright? Again, if our diagram was in centimeters, we'd put centimeters squared. But considering it's in meters, we'll put meters squared. One last part of the question. It told us to give our answer in 3 significant figures. Alright? Whenever you get a question telling you to put in 3 significant figures, you have to always round up to 3 significant figures, and you have to also denote it. So we're going to just put 3SF. That way the marker knows we've rounded it up. So if your value had some decimals in it, you would round it up to 3 significant figures, and you have to denote this by 3SF.